Hi, I'm Daniel. Have you ever wondered about the history of the microscope? No? Well, too bad. I'm gonna tell you all about it. The earliest recording of magnification would be when ancient Assyrians discovered the magnification properties of glass spheres at around the time of Christ. About 100 years later, ancient Romans were experimenting with glass and found that, by making a piece that was thick in the middle and thin on edges, the glass would make objects on the other side look larger. This was the first recorded production of a lens, which is actually derived from the Latin word for a lentil beam, which the lens resembles in shape. Claudius Ptolemy, a 2nd century mathematician in Alexandria, wrote about the optical properties of these early lenses. He also wrote about how water had similar properties and actually recorded the refraction constant of water. Despite this knowledge of lenses, however, nobody would use them until over 1,000 years later. During this time in the 1300s, lenses were used in spectacles to help people see better. Also at this time, the first microscopes were created but could only make object look 6 to 10 times bigger. Therefore, due to this low magnification power, they were called flea glasses, as fleas and other insects were interesting to view under them. At around 1590, Dutch spectacle maker Zacharias Janssen and his father Hans Janssen discovered that if you put 2 or more lenses in a tube, the object at the end would appear much bigger than under a single lens. They had made the first compound microscope, a design that would be improved upon over the next couple of centuries. In the 1665, scientist Robert Hooke published a paper detailing the many discoveries he had made using a microscope. In it, he described tiny structures in a piece of cork that he thought resembled jail cells. Therefore, he coined the term cell that is still used in biology today. Hooke also improved upon the design of the compound microscope and is credited as the one to first use the basic 3-lens configuration that is still used today. However, improving the design of the microscope wasn't the only innovation happening at the time. Scientist Antony van Leeuwenhoek created simple microscopes with incredibly powerful lenses. These lenses had magnifications of up to 200 times and allowed Leeuwenhoek to see single-celled organisms such as bacteria for the first time in history. However, because he kept his lens-making techniques secret, his innovation died with him in 1723. After the innovations of Hooke and Leeuwenhoek, there were 3 great problems with microscopes that needed to be fixed. The first of these problems was chromatic aberration, the unequal bending of different colors of light when passing through a lens. When the light reaches a second lens identical to the first one, the colors will distort even more, making the problem noticeable. In the 1730s, British inventor Chester Hall fixed this problem by making a second lens of a different shape that fixed the chromatic aberration of the first lens. This innovation helped create telescopes and microscopes without the distortion of color. The second problem microscopes faced was spherical aberration, which is the unequal bending of light that passed through different parts of the lens. In 1830, physicist Joseph Lister discovered that, by placing lenses at a precise distance from one another, the spherical aberration of all but the first lens could be eliminated. The third and final problem facing microscopes was the fact that in order to reach both high magnification and resolution, the cone of light produced by the microscope needs to be as wide as possible. In the 1870s, physicist Ernst Abbe was the first to use water and oil immersion lenses. By immersing the lens in oil or water, the cone of light was widened, allowing higher resolution and magnifications to be reached. With these lenses, the highest magnification of a light microscope had been reached with a magnification of over 2,000 times the original size. To reach magnifications greater than that, one would have to turn to electron microscopes which use electrons rather than light to view the specimen. However, that's a discussion for another video. I hope you have enjoyed this one. Again, this has been Daniel, presenting you the history of the microscope. Arrivederci.